Section 3.2 is about functions. Um, Function is a special relation between what? The independent variable x and dependent variable y. So we'll get to that in a minute, but let's first define what a relation is. Relation is a collection of set of order pairs of numbers. So if you have a bunch of order pairs of numbers and you put them in a bag or collect them in one spot, so that collection is called a relation. So a relation is gatherings or collection of bunch of order pairs of numbers. Each of these pairs, the first number is called first component of the order pair. The second one is called the second component of the order pair. So this is a relation, so is this guy. However, function is a special kind of relation, still is a collection of order pair, but you just can't have any old order pair in the collection. No two order pairs can have the same first components, which means the x values. In other words, if you look at the first relation, neither of these order pairs, they have the same x value, because we have a relation which no two order pairs have the same x values, so that relation can be also known as a function. So therefore, the first example number 1, is a function. Why? Because no two order pairs have the same x value. On the other hand, if you look at the second relation, notice these two order pairs have the same x values. So this collection cannot be called function. So if it's not a function, then it's what? A relation. Do you see it? So a function is a special case of a relation in which no two order pairs have the same x values. However, once you decide you have a function, the first component of any function is called domain of that function. For instance, the domain of this function right here is -1, 4, 2, let me see, and 7. This guy. Remember, we decided this is a function and this guy is a relation. So the x values of a function is called domain. So this is like domain. And the y values, so that would be like the second component of any order pair in a function, any order pair in a function is called a range. That's range. So in this case, the range of this function happens to be the second components, which happens to be the y values. So I would say the range is let's say, 3, 2, 1, 6, and 5 from here. So that would be 3, 2, 1, 6, and 5. So once again, function is a special kind of relation in which no two order pairs have the same x values. Once you made sure no two order pairs have identical x values, then the first components of that order pairs are called domain, and the y values of all those order pairs in a function is called a range. So that's domain and range. Sometimes they give us graphs or pictures and they go, can you tell which of these graphs belong to a function? Well, in order to do that, I don't have an order pair. I have a bunch of pictures. So what we have a test, as some of you may know. It's called vertical line test. What does that mean? That means if we draw a vertical line on the graph and it intersects the graph at only one point, it goes through the graph at only one point, then the given relation is a function. That means the picture is a picture of a function. Otherwise, it will be called a relation. So what that means is the following. Okay, suppose I'm given this picture. I want to know if this picture belongs to a function or not. So what do? I graph them, I draw a vertical line, and I notice no matter where I draw the line, that line is going to go or cross the graph at only one point. So therefore, this would be the graph of a function, correct? On the other hand, if I draw the vertical line on this picture, that also goes through the graph once. So this guy is a picture of a function. Excuse me. Now, if I draw the vertical line on this third graph, notice the line goes through the graph twice. So therefore, this circle cannot be the graph of a function. So we call this the graph of a relation. So when we are given pictures and they want you to decide or find out if the picture belongs to a function or not, apply the test called vertical line test. Draw a line over your picture, mess up your picture, and see if your line, when you graph it on your picture, goes through one point or more than one point. If it goes through one point, then it's the graph of a function. If it goes through more than one point or intersects or crosses your graph more than one point, then it's a relation. So the 64 million bucks question is, why do we care if we have a relation or a function? Well, it turns out functions in real life, they have a lot of applications, because they describe the relationship between an independent variable x and the dependent variable y. For instance, in real life, you might say, to successfully pass this class, we need to spend time to learn the topics covered in this class. So we can tell passing this class or any class is a function of time spent, right? So basically, we are required to come up with a relationship between an independent variable and dependent, meaning the success of your passing the class successfully solely depends on how much time you spend for the class. The less time you spend, the less likely you're going to pass the class successfully. The more time you spend, the more likely you're going to pass the class with a high grade. So passing this class, therefore, we say is a function of time. Do you see it? So things like this happen in real life, and then we can tell, we can then predict using the equation, the future. Based on that relationship, we can predict what's going to happen in the future, which is coming up next. So now we have functional notations. Okay, now that we know a little bit of function, what kind of symbols do we use to denote the functions? Here's my typical example, which I usually give in the classroom. The question is, find y if x is 2 and y is equal to x plus 4 and y is equal to 2x. Okay, obviously the idea is find y when x is 2, but the problem is you got two y's. Sometimes y is equal to x plus 4, sometimes it's equal to 2x. So which of these y's should I go and replace the x with? 2. In other words, if I take the first equation and replace the x with 2, so I get 2 plus 4, which is 6. On the other hand, if I take the second equation I get what? 2 times 2, which is 4. So which of these answers is the acceptable or correct answer? So as you can tell, there is a really confusion between, oh my goodness, which of these guys happens to be the answer? So therefore, we are desperate to learn about what specific sign or symbol so we can get confused when it comes to situations like this. So functional notations, which are what I call them nicknames for y. So instead of calling these guys y, we're going to give these guys a nickname. So these are the commonly used notations in the land of mathematics, specifically algebra. So f with a parentheses and x in it, you read this as f of x. Remember, this is just a what? A nickname for what? For y. So instead of calling y, we're going to call this, y f of x. This guy is, you read this as a g of x. You read this as what? H of x. You read this as h of t. You read this guy as what? S of r, and so on and so forth. So all of these guys happens to be what? Nicknames for y, so you can choose any of those depending on the content of the problem. So going back to the problem, previous problem, if I call this f of x, which is just a nickname for y, and call this guy g of x, which is just a nickname for what? Y, now I can say, look, given f of x is equal to x plus 4 and g of x is equal to what? 2x, could you find f of 2? So the idea is find what? F of 2. So what does that mean? F of 2, which is denoted by this notation, is just a nickname for what? Y in this equation, because I mentioned the letter F, not G. So I'm not going to go over this guy. I'm going to what? Go over this equation in the box because it says F, not G, and replace what? X with what? 2. Why would I do that? So I can find what? Find the y value. Remember, f of x is what? Is a nickname for y, correct? So here's what we do. We go, okay, f of 2 is equal to what? Go back to the equation and replace the x with 2. And lo and behold, you get 6. So the answer is f of 2 is equal to 6. Okay, if anyone asks, what is it that you just found? You would tell them, when x is 2, I just found out what? Y is 6. So this is an order pair. It's like 2 comma 6. You see it. So when x is 2, y is 6. On the other hand, let's call this what? Part A of the problem. Now let's say part B, g of negative 1. If they say find g of negative 1, now you have to go to the g function. So because they said g of negative 1, so that means they want you to go find this y, not that y. Because remember, we gave a nickname for this y, g of x. So what you do, you kind of go to that equation, replace the x's with what? Negative 1, correct? So you would get 2 times negative 1 is equal to negative 2. So what does that mean? That means g of negative 1 is equal to negative 2. But if anyone asks you, what is it that you found here? You would say, hey, I was given x equals negative 1. I found out the corresponding y value for negative 1 is negative 2. Do you see it? So please get used to these kind of notation because we'll be using these extensively in upcoming sections and chapters. The next top item is evaluate. Evaluate means find the value of, okay, the following functions, correct? If f of x is 4x minus 3, can you find f of 2 and f of 0? That's how you read this, f of 2 and f of 0 if f of x is 4x minus 3. So keep in mind the order pairs will be x comma f of x. So remember, this is just the nicknames for y. Instead of saying x comma y, we are saying x comma what? F of x. So to find f of 2, you go back into the equation and replace the x's with 2. And you get 8 minus 3 equals 5. Remember, this is not f times 2. You read this as what? F of 2. That means when x is 2, please find out what y is. So if anyone asks you what is it that you just did here, you can tell them in this equation, they told me x is equal to 2, and I found out y, the corresponding value for y is 5. So I found an order pair. Do you see it? What would be like? That's part A. Part B would be f of 0. Go back to the equation, replace the x's with 0. So you get negative 3. So how would you write the answer? F of 0 is negative 3. That means when x is 0, y is negative 3. Here you would write the answer as f of 2 is equal to what? 5. So these are the final answers, correct? Final answers. Final answers. H of z is equal to absolute value of minus 2z. So remember, in this case, the order pairs is z and h of z. Remember, h of z is just a nickname for y. And instead of x, now the independent variable is z. So don't panic. All we have to do is replace the z with these numbers. So question is find what? H of 6. So that means go back to this equation inside the box, replace the z's with 6. So you go inside the absolute value bar and you kind of what? Do this, replace the z with 6, work it out, you get 5 minus 12, which is absolute value of negative 7, which is 7. Remember, absolute value of a number is positive. So how do you write the final answer? You would say h of 6 is 7. What does that mean? This means when z is equal to what? 6, y is equal to 7. Okay, remember, instead of x, I had z. So excuse me, whatever is inside the parentheses, that's your independent variable. This is independent variable. You know what that means. That means, excuse me, you give me the value of z or value of x, I find the value of y. In other words, the value of y solely depends on what you give me for value of x or z in this case. That's why it's called independent. But the y value depends on what z is in this particular case. That's why y is what? Dependent. Z in this case is what? Independent. So you told me z is 6. I found out when what? Y is 7. If you would have given me a different value for z, of course I would find a different value for y. But in this case, y is called h of z, which is a nickname for y. Okay, part B is h of 5/2. So go back inside the what? Absolute value bars. Work this out. Remember, order of operations says you have to do multiplication first. So if you multiply these two fractions, you cross cancel the 2's. So you get 5 minus 5, which is 0. Remember, absolute value is a neutral number, so it doesn't have a what? A bars around it. So how do you write the answer? You go h of 5/2 is equal to what? 0. That means when what? Z is 5/2, y is 0. Okay, g of t is 4 minus 3t plus 16t squared minus what? 2t cubed. Question is what? Can you find g of 0? You know what that means, don't you? That just means what? When t, remember this is the independent variable, when t is 0, could you find the y value? So what you do, you go inside this equation right here, replace all the t's with what? 0. Okay, and these guys happen to be equal to 0, so the answer is just 4. So you would write the answer as g of 0 is equal to 4. So what does this mean? This means when t is 0, y is 4. Remember, the independent variable happens to be t, not x. And how could you tell? Because on the right side, you don't have x's, you have t's. So this cannot be called g of x. It has to be called what? G of t. Right here on the right side, you had z's. So this cannot be called h of x. It has to be called what? H of z. So the independent variable always goes inside the parentheses to denote the y value. Okay, so that would be A, this would be B. How about g of -1? So go back to the equation, replace all the t's with what? -1, correct? And work this out. First, you do the exponents. So this would be like, let's say, 16, -1 squared is 1, -1 cubed is still -1. So here you get 4, -3 times -1 is +3. This guy is 16 and that guy is 2. So this is like 7 and that's like 18. Is that right? So that's like 25. Is that right? So how do you write the answer? G of -1 is equal to 25. Final answer. S of t is the square root of t plus 3. So the y is given a name like s, an independent variable is t. So the ordered pairs are t comma s of t. Do you see it? So how do you do this? Remember, on the right side, you got t's. So this cannot be s of x. It is called s of t. So to find s of 0, -3, go back to this equation inside the box, replace the t's with -3. That would be square root of 0, which is 0. Remember, this is not s times -3. Please do not confuse this notation with what? With multiplication. S of -3, you read this as s of -3. That means when what? T is -3, what's s? Or y, which is s is a nickname for y. Otherwise, if I meant to say what multiplication, then I would write it this way. So this is like -3 times s. But the minute you put the number inside the parentheses, then that's a functional notation. So warning, please make sure you don't get the notation messed up with operation. Okay, part B, s of 6. That will be 6 plus 3. That's the square root of 9. The square root of 9 is 3. So how do I write the answer? S of 6 is equal to 3. Correct? All right. Finally, g of x. So you have a function whose name is g, and the independent variable is x. Notice you got nothing but x's on the right side. Question, what's g of 0? So go back into this equation, replace the x's on the right side with 0. So that's -2 over -2, which is 1. So how do you write the answer? G of 0 is 1. If anyone asks you what is it that you just found, you would tell them when x is 0, I just found out where y is 1. So that's part A. Part B is g of, let's say, what was it? 2. Well, that would be like 2 cubed minus 2. over 2 minus 2. That's 8 minus 2 over 0, which is 6 over 0. Remember, this is like how many times 0 divides into 6. I can't tell you what the answer is, so it's undefined. So how do you write the answer? You would say g of 2 is what? Undefined, and box the answer. Here you would say what? G of 0 is equal to 1, and box the answer. So, does this show up in real life? Yes, it does. As a matter of fact, as I said, anytime something is what? Depend on something else, you can express that relationship as a function. Provided what, you don't have identical x values of the domain. Remember, you cannot have what? Same independent variable for different what? Dependent variables. So let's see now. Here's the problem. The temperature capital T in degrees Celsius, remember in overseas, they what? Have a unit of measurement Celsius. In this country, we have Fahrenheit. In sauna is n minutes, so n is the minutes, after being turned on is given by this function right here. How do you read this? T of n is equal to negative 0.03 n squared plus 1.5 n plus 14. So this is given. Find the sauna's temperature after 3 minutes. Remember, n is the time, T is the temperature. So in real life, we don't say find T of whatever. We say find the sauna's temperature after 3 minutes. In the land of mathematics, this translates into T of 3. That's how you read this, T of 3. That means when n, which is the independent variable, which is the time, is 3 minutes, what would be the temperature of the sauna? So how do you do this? You go back into the box, replace what? The n's with 3. And then you follow the order of operation and work this out. Remember, first you gotta what? Do the exponent. So that's 0.03 times 9 plus 1.5 times 3 plus 14. And this guy comes up to 18.2 degrees Celsius. So that would be the temperature of the sauna after 3 minutes. And there you have it. Part B is, what will be the temperature of the sauna after 12 minutes? In the land of mathematics, after 12 minutes, that translates into finding T of 12. Okay, so T of 12, if you go back to this equation, replace the what? N's, which happens to be the time because they said so, and is the minutes after being turned on, the sauna, that is. So this would be 12 squared plus 1.5 times 12 plus 14. What are you doing? Replacing the n's with 12, the number which was given to me. And if you work this out, first you do the exponent, which is negative 0.03 times 144 plus 1.5 times 12 plus 14. And this guy comes up to 27.68 degrees Celsius. So notice, in real life, you can express the relationship between an independent variable. There are relationships, special relationships, which they relate the independent variables to what? Dependent variables, such as this problem. So that would be pretty much it for this section. Thank you.